Could a newly found alien world become our home one day? We will have to wait till the end of this year to know if the planet has an atmosphere that supports human life or not, depending on whether it is cool enough or not. The new alien world may have an iron-silicate composition similar to that of Earth, which makes it a good candidate to host us in the near future. However, its surface temperatures are like those of Venus, which is not so great. What it means is that the new world is hot and dry, interspersed with volcanoes and glowing lava rivers. Also, because its orbit is so tight, it is tidally locked, always showing the same face to its parent star, as the moon does to Earth. Therefore, this new world, although promising, may well have a blisteringly hot dayside and a much colder night side, another possible impediment to life as we know it. But there remains ample reason to get excited about it. Its proximity to Earth and other characteristics make it a great laboratory for learning about planetary atmospheres. The best candidate to make such observations is NASA's newest telescope, which is scheduled to launch late this year. Soon after the telescope becomes operational, scientists will be able to know if the planet has an atmosphere or not, and, if yes, what is its composition. But for now, the newly discovered alien world is helping astronomers understand what the atmospheres of rocky planets are like. I'm Michael Taylor and this is my latest edition of the Investigative Intelligence Report. The newfound exoplanet, Gliese 486b, circles a dim red dwarf star just 26 light years from Earth and is about 1.3 times larger and 2.8 times more massive than our home planet. A new study has just reported, Gliese 486b whips around its host star once every 1.47 Earth days, and it crosses that star's face from our perspective. Gliese 486b is therefore the third closest such transiting alien world known, and the closest one that orbits a red dwarf with a measured mass. The star Gliese 486 is about 30% as massive as our Sun. Besides, it has just been determined that Gliese 486b has a likely surface temperature of around 800 degrees Fahrenheit or 430 degrees Celsius. Probably cool enough to support an atmosphere, and hot enough for that atmosphere to be studied from afar. This combination of physical and orbital characteristics of Gliese 486b makes it the Rosetta Stone for atmospheric investigations of rocky exoplanets. Study lead author Trifon Trifonov, of the Max Planck Institute for Astronomy in Heidelberg, Germany, told Space.com. The Rosetta Stone, which was discovered in 1799, famously allowed archaeologists to translate Egyptian hieroglyphics for the first time. Trifonov and his colleagues spotted Gliese 486b using the Carmine spectrograph instrument, which is installed on the 3.5 meter telescope at the Calar Alto Observatory in Spain. Carmine finds planets via the radial velocity method, noticing slight wobbles in a star's motion caused by the gravitational tug of an orbiting world. The instrument detected such a wobble with Gliese 486, one that recurs every 1.47 Earth days. The team then studied Gliese 486 with NASA's Transiting Exoplanet Survey satellite named TESS. As its name suggests, TESS finds transiting worlds, flagging the tiny brightness dips they caused when crossing their host stars' faces from the spacecraft's perspective. TESS saw the brightness dip with Gliese 486. And the 1.47 day timing matched, confirming the presence of an alien planet in the system. Trifonov and his team then characterized Gliese 486b using the TESS and Carmine's data, as well as information from another spectrograph known as Maroon X, which is on the 8.1M Gemini North Telescope in Hawaii. The exoplanet is likely to have an iron-silicate composition similar to that of Earth, the researchers wrote in the new study, which was published online on Thursday, the 4th of March, 2021, in the journal Science. The surface temperature, however, is closer to that of Venus. So, Gliese 486b is not a great candidate for life as we know it. It is envisioned as a world that is hot and dry, interspersed with volcanoes and glowing lava rivers. Also, because its orbit is so tight, Gliese 486b is likely tidally locked, always showing the same face to its parent star, as the moon does to Earth. So, the exoplanet may well have a blisteringly hot dayside and a much colder night side. Another possible impediment to life as we know it. But there's still ample reason to get excited about Gliese 486b. Its proximity to Earth and other characteristics make it a great laboratory for learning about planetary atmospheres. The best candidate to make such observations is NASA's $9.8 billion James Webb Space Telescope, which is scheduled to launch late this year. Soon after the telescope becomes operational, scientists will be able to know if the planet has an atmosphere or not, and, if yes, what is its composition. But Gliese 486b is not the only space phenomena that made the news this week. Scientists announced in early March that they observed a previously unknown phenomenon. A 620-mile wide swirling mass of plasma that roiled for hours in Earth's upper atmosphere, raining electrons instead of water. The researchers labeled the disturbance a space hurricane because it resembled and behaved like the rotating storm systems that routinely batter coastlines around the world. But until now, they were not known to exist. It wasn't expected, said Larry Lyons, a professor of atmospheric and oceanic sciences at the University of California, Los Angeles. It wasn't even theoretically known. Lyons was one of the authors of a study about the finding, which sheds new light on space weather events, that was published online the 26th of February in the journal Nature Communications. Scientists from China, the United States, Norway, and the United Kingdom found the space hurricane while combing through satellite observations from August 2014. As satellites orbited around the planet and passed over the North Pole, they caught glimpses of a massive disturbance in the upper atmosphere. The spiral-armed space hurricane swirled roughly 125 miles over the North Pole, churning in place for almost 8 hours. Scientists could see flows of plasma going around, which were like the winds of the space hurricane. These flows were strongest at the edge and decreased when they moved toward the eye in the center, before picking up again on the other side, just like the flow of air in a regular hurricane. But that's perhaps where the similarities end. Unlike regular hurricanes that dump huge amounts of precipitation over Earth's surface, scientists observed electrons raining into the upper atmosphere instead. Space hurricanes, like other space weather events, are caused by streams of plasma unleashed from the sun in what's known as the solar wind. As these clouds of charged particles hurl through space, they can fuel magnetic storms and trigger stunning displays of the northern or southern lights. Tropical storms are associated with huge amounts of energy, and these space hurricanes must be created by unusually large and rapid transfer of solar wind energy and charged particles into the Earth's upper atmosphere, study co-author Michael Lockwood, a professor of space environment physics at the University of Reading in the UK, said. Scientists routinely monitor space weather because radiation from particles from the sun can wreak havoc on satellites in orbit and can occasionally disrupt infrastructure on the ground, such as surges in power lines. Since the observed space hurricane occurred over the North Pole, it's not thought that it would pose many dangers to people at lower latitudes, but there are implications for communications and navigation systems. He and his colleagues are planning to conduct follow-up studies to determine how often space hurricanes of this size and duration occur, and whether smaller, shorter storms happen more frequently. According to a press release by the University of Reading, this space hurricane analyzed by the scientists in Earth's ionosphere was found to be spinning in an anti-clockwise direction with multiple spiral arms and lasted for almost 8 hours before breaking down. This analysis led to the creation of a 3D image of a 1000 km wide swirling mass of plasma several hundred kilometers above the North Pole. The 3D image resembles the hurricanes that occur in the Earth's lower atmosphere. The occurrence of tropical storms is associated with huge amounts of energy. These space hurricanes are also a result of unusually large and rapid transfer of solar wind energy and charged particles into the Earth's upper atmosphere. Until now, it was uncertain that space plasma hurricanes even existed. So to prove this with such a striking observation is incredible, said Professor Mike Lockwood, a space scientist at the University of Reading. For the analysis, scientists followed methods including checking data from the satellites, radars, and other sources for consistency. This occurrence of a hurricane during a period of low geomagnetic activity suggests they are more common than you think within our solar system and beyond. I'm Michael Taylor and you've been watching my investigative intelligence report. I hope you enjoyed watching this video. Don't forget to subscribe and like my video before you leave. And please leave me a comment so that I can thank you later. Until next time, be safe and bye for now.